Hello students, welcome to class 11 physics class. Today we discuss the last part of the gravitation, that is just about satellite orbital velocity, because this year Kepler's law and its applications, derivations will not included in your syllabus. So let's start today's class. So first of all we have to understand what is a satellite. We also each and everybody heard this word satellite. We also see in a Discovery Channel or in a news channel that from America, from India, from China, they having their satellites also, and whatever the channels we see in the TV, all that broadcasting, that all from the that satellite. So what is a satellite? Satellite, it is a body which continuously revolves around its own uh, orbit, much larger body in a stable orbit. That orbit will be stable. So satellite, it is a body which is continuously revolve on its own around a much larger body in a stable orbit. So for example, if the moon, so actually satellite, there is a two types are there. So for example, moon is a body which where they will also revolve their own axis, and they also rotate around the earth. So that is a larger object, and that stable orbit, that orbit of the moon, that is a stable orbit. That's why the moon is called the satellite of earth. Earth has one satellite only, we know that. So this is a satellite. So now the satellites are two types. One is a natural satellite, one is a artificial satellite, and their examples also be different. Natural satellite, that one, that moon, each and every planet has some satellites. Some have one, some have two, some have four, three. Uh, so the planets Jupiter and the Saturn have 14 and 12 satellites respectively. So these are the natural satellite. The satellite is created by nature. We the moon, that is a naturally created. It is not a man-made. That's why this type of satellite is called natural satellite, and they will revolve around a heavenly body or the larger body, and they also rotate around their axis in a stable orbit. Artificial satellite, that is called a man-made satellite, which is launched from some uh, s- uh, f- from some country. That so the India also has some satellite, America also has some satellite, Japan, China, they're having the different satellites. That is man-made satellites. That's why this is called artificial satellite. First satellite is discovered by Russians. They will first put to an artificial satellite, that is Sputnik 1, in an orbital around the Earth on October 4, 1957. After that, the many satellites, now we live in 2020. So within this so many years, many satellites are discovered by scientists, and they will also revolve around the different planets. The To study the various phenomena in the outer regions of the Earth atmosphere, the artificial or this man-made satellite gives us the the outer region of the planet. If we consider about the Earth atmosphere, what will be the outer atmosphere of the Earth? So Indian entered space age on April 1975 by putting in orbit the first satellite, that is called Aryabhatta, from Russian soil. That is the first Indian satellite. India list included important satellites, that is INSAT 1A, INSAT 1B, INSAT 2B, INSAT 2D, etc. These are the many satellites they will launched. Okay, but the first one is the Aryabhatta. So in this way, you can also define these things: an object orbiting around the sun, earth, or any colossal body or the celestial body is known as as a satellite. There are two major types. When it comes down to the satellite, it is a natural and the other is a man-made. Some example: natural satellite, that moons, and the comets. Jupiter has 67 natural satellites. The Earth has only one, that is a moon, that causes the tides in the sea. Okay, and the man-made satellite that are the uh, Aryabhatta, Sputnik 1, Inset 1A, Inset 1B. These are the examples for man-made satellite. Now we discuss the orbital velocity. Orbital velocity, from this term we can understand what is the definition. The velocity required to put the satellite into that orbit, into its orbit around the earth, because here we discuss about the earth, that's why we consider around the earth. That velocity is called orbital velocity. Each and every satellite has their own orbit. So the minimum velocity we require to put the satellite into its own orbit around the earth, that velocity is called orbital velocity. How we can prove these things? Here you see that in this diagram, earth, we consider the earth, its mass is capital M, its radius is capital R. A small mass, that is small m, that is the mass of the satellite, it is revolve around the earth in a in fixed orbit, and the distance from the earth surface, that will be h. So the from the center of the earth, its distance is r plus h. So we know that whenever any object is revolve around a circular path, circular orbit, it there is a one force that the velocity also acts tangentially. Each and every point on that circular path, the velocity act tangentially. Here the VO, that represent the orbital velocity of the satellite, and it is also act tangentially. So, according to the law of gravitation, so one force of attraction will act between the earth and that satellite. So, that is equals to F equals to gmm by r plus h whole square, because the distance is r plus h. The object or the satellite, it is not on the earth. The satellite, they are having some distance from the earth's surface. That's why the distance is r plus h. Now, we know that to keep the satellite in its own orbit, another one important force we require, that is called centripetal force. That is called centripetal force. So whenever that satellite is revolved around the earth, one force, that is gravitational force of attraction, also acts between them. Another one force we have, that is centripetal force, it is required to keep the satellite in its own orbit, and that expression we know that that is mv square by r. So here we write m v0 square by r plus h, that if. So both are the expression of force, and it will, the satellite will be kept in its own orbit when these two forces are equal to each other. If one force is more, then the satellite is not in its own orbit. It will either far away, or it will collide with the earth surface. So it will balance. When it will be balanced, when this two type of force, the force of gravity and the centripetal force, these two forces are equal to each other, then only the satellite in a, be in its own orbit. So we can write gmm by r plus h whole square, that is equals to mb square by r plus h. So from there we can find out v0 expression, that is equation number 1, root under gm by r plus h. Okay. Now this is also one expression. Now we try to we want to express the v0 in terms of small g, acceleration due to gravity. So we use the relation between small g and capital G, that g equals to gm by r square. So gm equals to gr square. So in place of gm we write gr square. So after solving we get r root under g by r plus h. This is another one expression for orbital velocity. Now this equation 1, and this is in terms of capital G and capital M, and this is in terms of small g. Now once thing that if the satellite revolves very close to the surface of the earth, So, but not on the surface, very very close. So we can say that h is a very negligible value. So 8 must be 0. So in that condition, the V0 expression will be root under g into r, root under g into r. And if we put the values over there, g and the r, so we get the value of the orbital velocity, that is 7.92 kilometer per second. So this is the expression and this is the value of the orbital velocity of an satellite. Now some important points you have to keep it in your mind. First, it is clear that orbital velocity of a satellite is independent of the mass of the satellite, because in that expression V0 equals to gr, or the first expression V0 equals to root under gm by r plus h, there is a no small m term. So it is independent of the mass of the satellite. Second number decreases with the increase in radius of the orbit and with increase in the height of the satellite. It will decreases with increase of the radius of the orbit. Here in the first formula you see that in the denominator we write r plus h. So it will, the value of V0 it will be decreased with the increase of the in the radius of the orbit and with increase in the height of the satellite. Another one depends on the mass and radius of the planet about which the satellite revolves. Here we consider the earth, so that in first expression you see that g, m and r and h, every term is there. So we can say that it will depends on the mass and the radius of that planet, that is here the earth, about which satellite revolves. Okay, this is all about the orbital velocity. Now the relation between orbital velocity and the escape velocity. Escape velocity in last class we discussed. Escape velocity we get VE, V suffix E, that is equals to root under 2 into g into r, and here we get V0 equals to root under g into r. The all are from the earth surface, and the V0 equals to root over gr, this is also very close to the earth surface. So if we divide these two values or these two expression, we get VE, that is equals to root 2 into V0. VE, that is equals to root 2 into V0. That means escape velocity of a body from the earth surface is root 2 times its velocity in a circular orbit just above the earth surface. Escape velocity is the root 2 times of orbital velocity. Next is geostationary satellite. What is the meaning of geo? Geo means earth, stationary means at rest. This means something which is at stationary. So satellite orbiting around the earth in an equatorial plane with a time period equal to 24 hours with the same speed as that of the earth. That's why we consider this is a stationary satellite, geostationary satellite. The if two objects having the same velocity, same the same direction, if they will go, so we can consider the second object and the first object both are at rest. Okay, that's why this type of satellite is called geostationary satellite, and appear to be stationary with respect to Earth. They also rotate around the earth with the time period of 24 hours. We know that the time period of earth, that is a 24 hours. So for that type of satellite also having the same time period, that's why we see that or that type of satellite are called stationary satellite with respect to earth. That is why we call geostationary satellite. These satellites can receive telecommunication signals and broadcast them back to the wide area on the earth. We use this, that whatever the TV channels we see, different channels, that is coming from that satellite, geostationary satellite. That is the insert group of satellite, insert 1A, insert 1B. Many satellites are there. Using that not only for the telecommunication, for also different purposes we also use. The one thing is this one, telecommunication and broadcasting uh, purpose we use this satellites. Necessary conditions for geostationary satellite: it should be revolve in an orbit concentric and coplanar with the equatorial plane of the earth. Whatever the equatorial plane, you know, I think the equatorial plane means in that plane they will be revolve. The time period, one is the time period of the revolution of the satellite will be 24 hours, same as that of the earth. It sense of rotation should be same as that of the earth. That means, and the earth, we know that the earth rotate from west to east, so this satellite also rotate west to east. And it should revolve at a height of nearly 36 kilometer above the earth surface, not so long, 36,000 kilometer above the earth's surface. These are the necessary conditions for geostationary satellite. Use, one is the communication, radio, TV, telephone signals, forecasting weather, determining the exact shape and the dimension of the earth, the studying materials, the studying upper regions of the atmosphere for cosmic rays, solar radiation. Different purposes we use the satellite, not only for the telecommunication, different purposes are there. Okay, these are the uses of geostationary satellite. So in this year, that Kepler's three laws also be included in this three, on the base of this satellites, sun, the planets, three laws also be there. That time that portion will be deleted for this year. So this is the last part from this chapter, gravitation. I hope you understand. If still, if you have anybody have any problem, please write in a comment box. Thank you very much. Stay safe, stay in your home. Have a good day.